More triangle proofs for us today. We're going to do a couple more before you get to your homework. This is 3 more proofs. Still focused on the 5 different ways for us to prove triangles are congruent. This one starts off with CB and GA being parallel. And I get that angle G is congruent to angle B. And that's all given to me. I'm going to darken in my marks a little bit. That's congruent to that. And then I've got these guys being parallel. Anytime we've dealt with parallel lines, I've told you please extend them a little and then cut with that transversal. And about 90% of the time, you're going to be doing an alternate interior angle. So we're going to talk about angle BCA being congruent to GAC. The reason is alternate interior angles. So parallel lines give me alternate interior angles congruent. Third thing, I've kind of preached them, but you got to make sure that you're looking out for vertical angles and shared sides. This guy's got a shared side. So CA is congruent to AC. Reflexive property. Now my triangles are congruent. All I have to do is copy down the prove line. And the reason is angle, angle, side. Next I've got VZ as the perpendicular bisector. That is 2 separate words that we're going to be able to tackle, that we're going to be able to use in our proof. So I got VZ is the perpendicular bisector of WX. Given. So VZ being the perpendicular, that means right angles. Bisector means cut in half. So we're going to get 2 different pieces of information for this guy. So perpendicular means they meet at 90. So VZ meets WX at a 90. So that means that this angle and this one are 90 degrees. So angle WYV and angle XYV are right angles. And this is definition of perpendicular. The reason that they are 90s is because something was perpendicular. Next, I've got this shared side up the middle, so VY is congruent to VY. Reflexive property. So right now I've got 2 things. I've got the side and the 90. Most kids are going to kind of want to lean towards HL, but that would mean we need the hypotenuse. And let's see if this will give us the hypotenuse. I've also got bisector. And bisector means cut in half. So VZ cut WX in half. So I'm just kind of making this dark, bold here. I'm cutting WX in half. And if I do that, that means Y is in the middle. So that means that WY is the same as YX. So WY is the same as XY. This is definition of bisector. We know that it's the same on both sides because the bisector cut it in half. That was its job. And now our last step is just that our triangles are congruent. And the reason is when you look at our triangle, it's not quite HL because I don't have the H. I don't have the hypotenuse. So this one is actually side, angle, side. And some kids ask me, does the proof have to go in exactly that order? And I say, nope. As long as this guy comes last, these 3 could have been rearranged in any order. So this one could have been step 2, this one could have been 3. Any of these guys could have been rearranged. You don't have to do it in the exact same order that I have it. Last proof for today is this guy right here. Getting our given down, we know that AB is congruent to DE. And AB is parallel to DE. So AB is parallel. Good, I have that. Also, they told me that AB is equal to ED, so I'm going to give that a tick mark. So right now I've got one side. We have talked before about vertical angles, so I'm going to go ahead and mark those, and we're going to talk about them. So angle ACB is congruent to angle DCE. Vertical angles congruent. So now I've got two angles, or I'm sorry, one angle going on with a side. We have parallel lines, so maybe darken those in a little bit. And now, depending on which transversal you draw, you're going to come up with a different ending answer. Okay, so I'm going to do this in two different ways. I'm going to show you two different ways to do this. So if you draw this transversal, you're going to end up with these two guys being alternate interior angles. So angle B and angle E. If you go the other way and you draw this transversal, then it would be A and D. And that's still parallel lines, giving me AIA congruent. When you get down here, your triangles will still be equal. ABC is congruent to triangle DEC. Whoops, triangle, not A. But depending on which one of these you picked, it will be a different theorem. So if you picked B and E, how I kind of have it drawn here, you have an angle side. If you went with A and D instead, you wouldn't have this guy. Sorry for all the pen. You would have this one. And so you would end up going this way. You would also have an angle side. Sometimes, depending on which one you pick, it might switch up in the end which theorem you end up using. And it doesn't matter which one of these you pick. You just had to pick one of them to get your angle. Some people skip the vertical angle altogether and just do both of those guys. And then you would have an angle, side, angle, totally different than what we got. So depending on how you and maybe your friend who you're comparing to have done it, it might not necessarily be wrong. You guys might have the same proof or a legitimate proof, just did it in different ways.